Hello, Santosh here. Today I am giving my fifth lecture on the hydrology. That is nothing but the groundwater, and which is very important as far as hydrology subject is considered. Sometimes that hydrology is termed as a groundwater hydrology also. This lecture might be useful for the students who are appearing for the MPSC mains examinations, as well as for the students who are appearing for the diploma and degree level of examinations, as well as this lecture might be useful to you for GATE and other type of competitive examinations. So don't miss to subscribe my channel and get more and more marks in competitive examinations. Let us start with groundwater. First of all, how the groundwater is defined. Any water that can present below the earth's surface is termed as a groundwater. The water which stands below the earth's surface is the groundwater. The presence of water is due to seepage or percolation of water. And in short, occurrence, OMD, you must remember OMD. OMD means occurrence, movement and distribution of groundwater is termed as a groundwater hydrology. That occurrence, movement and distribution of groundwater is important in groundwater hydrology. Then classification of groundwater. First is the natural recharge. The main source of groundwater is the stream, river, lake or water flowing through the natural bodies. That is the natural recharge. And second is the artificial recharge. The main source of groundwater is due to seepage of water from canals, excess irrigation, leakage from the tanks and reservoirs, etc. This is the artificial recharge. Then we will discuss the important terms related to groundwater. These terms are sometimes asked in examinations, especially for objective type of examination. What is the aquifier? Aquifier, the geological formation. Aquifier, aquiclude, aquifuse, all are the geological formations. So aquifier is the geological formation which contains the permeable material which permits the storage and transmission. So aquifier permits the transmission also, and it permits the storage also. And such a geological formation is called as a aquifer. Generally it is made up of unconsolidated sand and gravel. Second is the aquiclude. Aquiclude is also geological formation of relatively impermeable material which permits the storage but not transmission. Impermeable means it permits the storage but it not permits the transmission. That is the aquiclude. Then aquifuse. Aquifuse is the geological formation of impermeable material which neither permits the storage nor transmission. So neither permits the storage nor the transmission. Such a geological formation is called as aquifuse. You must remember these terms. And last one is the aquitard. Aquitard is generally similar to aquiclude and it is also geological formation of semi-impervious material which permits the storage of water but obstruct the transmission, that obstruct the groundwater movement. And such a material or such a geological formation is made up of sandy clay. Then you must know the term porosity, which is denoted by the small n, and these terms occur in soil mechanics also, and it is very important in soil mechanics also. What is the porosity? Amount of porous space per unit volume of aquifer. Amount of porous space per unit volume of aquifer is called as a porosity. Porosity small n is equal to Vv divided by Vs, where Vv is equal to volume of voids divided by Vs means volume of aquifer or volume of that geological formation or volume of solids. If this n is more than 20%, then it is termed as a large porosity. If that n varies between 5 to 20, it is medium porosity, and when this n is less than 5%, this is the small porosity. Then we will discuss the another term, specific yield, which is important for groundwater. The actual volume of water can be exerted by the force of gravity from unit volume of aquifer material is known as a specific yield. That is the actual volume of water exerted by the force of gravity from unit volume of aquifer material is termed as a specific yield, and it is denoted by SY. How SY is calculated? SY is equal to WY divided by V into 100. What is the WY? WY is equal to volume of drained water. And second term is the specific retention. First is the specific yield, then we will discuss the specific retention. The fraction of water held back in the aquifer is known as a specific retention, means that amount of water that is held back into aquifer material, and it is denoted by SR. SR is calculated in similar way. SR is equal to WR divided by V into 100, where WR is equal to volume of drained water. And what is the porosity? Porosity small l is equal to small n is equal to SY plus SR, means porosity is the algebraic sum of specific yield and specific retention. That is important. Then safe yield. What is the safe yield? The maximum quantity of water supplied by a reservoir with firm commitment or guarantee during worst dry period is known as a firm yield. म्हणजेच सगळ्यात वाईट सिच्युएशनला जी जास्तीत जास्त पाण्याची क्वांटिटी आपल्याला ॲक्विफायरपासून किंवा वेलपासून मिळू शकते, अशा पाण्याच्या व्हॉल्यूमला किंवा क्वांटिटीला सेफ यील्ड असं म्हटलं जातं. देन वी विल डिस्कस द कोएफिशियंट ऑफ ट्रान्समिसिबिलिटी, that is denoted by capital T, that is equal to B multiplied by K or BK. The rate of flow of water through vertical strip of water bearing material of unit width and full depth under unit hydraulic gradient and temperature of 20 degrees Celsius. You must remember this unit hydraulic gradient and temperature of 20 degrees Celsius. Such a questions are asked in the objective type of examination for that coefficient of permeability. What is that? That is nothing but the volume, rate of flow, that is discharge of water through vertical strip of water bearing material, and at what depth and at what width. It is at full depth and width is unit 1 under unit hydraulic gradient and at a temperature of 20 degrees Celsius. Then we will discuss the storage coefficient. The volume of water released from the aquifer of unit cross sectional area and full height of aquifer when piezometric surface declines by the unity. That is the storage coefficient. Then coefficient of permeability, that is K, that is also rate of flow of water per unit cross sectional area of aquifer under unit hydraulic gradient. That is the coefficient of permeability and it is denoted by K, and coefficient of transmissibility is denoted by capital T. Then this is very important law, Darcys Law, and it is asked in all competitive type of examination. What is the Darcys Law? The rate of flow, that is nothing but the discharge, is directly proportional to the head loss and cross sectional area of soil and inversely proportional to the length of sample. That Q is directly proportional to the delta H means head loss, A means area of cross section, and inversely proportion, that's why it is divided by L. Then that Q is denoted by I into A, that is Q is equal to, if constant is applied to that IA, Q is equal to KIA, where K is equal to coefficient of permeability and I is equal to head loss. I is equal to head loss means delta is divided by L, that is I, and A is equal to area of cross section of the soil. So Darcys Law is nothing but the relationship between the head loss cross sectional area and length of sample with respect to discharge. What are the limitations of the Darcys Law? It is applicable for the laminar flow only. Laminar flow means streamline flow, and another flow is turbulent. It is not applicable for the turbulent flow, but it is applicable for the laminar flow. There is no known lower limit for application of Darcys Law. That is the second limitation. Effective size of soil particle not greater than 3 mm for application of Darcys law. So it is applicable for the size less than 3 mm, and when the Reynolds number is between 0.10 to 75, this law is valid. That is also important. Then types of aquifer. We will discuss the types of aquifer. First type of aquifer, which permits the storage as well as transmission of water. That first type of aquifer is unconfined oblique non-Aristeian aquifer. In non-Aristeian aquifer, the topmost bearing strata, that is water below the surface, having no impermeable overburden. So impermeable overburden is not there lying over them. Ordinary wells through such a aquifer is known as a unconfined wells, 2 to 5 meter diameter. Water table and level of water in the well is same as that of water level of the ground. These types of aquifers are called as unconfined aquifers. Please look at this figure. This figure shows this red material, all dotted red material is the pervious material, and these are the wells of 2 to 5 meter in diameter, and the level of water in the well as well as groundwater actually at the same level, and such a type of aquifer is called as a unconfined aquifer. Aquifer is nothing but the geological formation which permits the storage and transmission of water. Then second is the confined aquifer. When aquifer is closed between upper surface and lower surface by aquicludes, sometimes water may be gush out automatically. They are known as a flowing or as well as Aristeian wells also. So confined aquifer wells are called as a flowing wells. The wells which are constructed in confined aquifer are termed as a flowing wells or Aristeian wells. And we will discuss it briefly by the diagram also. First of all, we discuss the third type, that is perched aquifer. It is the special case of unconfined aquifer. Impermeous zone is formed which supports the pervious material within the zone of pervious material. Such an aquifer is known as a perched aquifer, and top surface of the water held in such an aquifer is known as a perched water table. So first we discuss the confined aquifer. The confined aquifer is in between two aquicludes. What is the aquiclude? Please look at this figure. This is one aquiclude and this is the second aquiclude. Aquiclude is nothing but the geological formation which allows the storage but not allows the transmission of water. And if water table is here below the first aquiclude, and if we construct the wells, this is the first well, then this is the water table, and if this is second well which is constructed at the level of groundwater, then the water is gushed out. So such a wells are called as a Aristeian wells or flowing wells. Okay. And third case is a perched aquifer. In perched aquifer, impervious body, this is the impervious body which is created in pervious material, and this is the original groundwater level, that is the first. And if impervious body is formed above that water table, then again pervious material is here above that impervious body, and due to pervious material the water is stored here also, and this water level is termed as a perched water table. And this is also important from examination point of view. So you must remember these diagrams. These diagrams are very important. Then method of determining the yield of well. Yield of well is nothing but the quantity of water obtained from that well. The first test is recuperation test or recovery test. This is very important and a very simple one also. When pumping is difficult for maintaining the level in well, in such a cases recuperation test is adopted. When pumping test is not difficult, then recuperation test is adopted. In this test, water is drawn from the well at faster rate to cause sufficient drawdown. the pumping is then stopped and water is allowed to rise at normal level, and the time taken to rise the water from water to normal level is recorded, and the discharge is worked out as follows. There is one formula for that recuperations test. The discharge is equal to 2.3 divided by T log of base 10 S2 divided by S1 and into A into S, and this is the S1. S1 means that is drained water level, and this is the S2, that is recovered water level, that is the S2. And this test is this test is also used to determine the yield. And second test is pumping test. This test is called as a Thies test, Jacob test, or Chaw test, or Thies, Jacob, or Chaw method. Huge quantity of water is drawn from the well to show the sufficient drawdown. The rate of pumping is changed and so adjusted that water level in the well remains constant. So there is no decrease in the water level, but the rate of pumping is adjusted in such a way that the water level remains constant, and such a rate of pumping is termed as a rate of yield. And difficult to adjust the rate of pumping to keep water level in the well constant, that is its limitation. And third test to determine the yield of well is the combined test. It is a combination of above two methods and used for non-Aristeian as well as Aristeian wells, that is combined test. Then construction of tube wells. Tube wells is nothing but the hapsa in Marathi, that is, or bore. Shallow tube wells. Shallow tube wells is first is the bored or bored tube wells. When water table exists at the shallow depth, construction with hand driven or power driven augers, we can construct the bored tube wells. Then second is the driven wells, constructed with the well point consisting of perforated point wrapped over a fine mesh with a conical steel shoe at the bottom and constructed on unconsolidated formation. Please look at this figure. This figure shows the perforated pipe which is driven into the ground, and here is that water table is shown here as a WT, and this is the conical shoe provided for that perforated pipe. Okay. And second is the auger which is used for construction of bores also. Auger has a cutting edge here, and this auger is lowered down into the ground to get certain depth or to carry out the excavations. Okay. Then jetted wells constructed to jetted wells are constructed by using the cutting action of high velocity water. In casing pipe, jetting pipe is lowered. So there is one casing pipe, and in that casing pipe the jetting pipe is lowered and high velocity of water is allowed to rush at the bottom, and it is constructed over unconsolidated formations such as sandy soil or sand, clay, gravel, and where there is a soft deposit, then this jetted wells or this jetting method is also used, or jetted wells are used. Then second types are the deep tube wells. Cable tool method is used. This is the important method, cable tool method, and it is asked in the examination. Second is the hydraulic rotary method for deep tube wells construction of, and third is the reverse rotary method. We will discuss this cable tool method. It is termed as a percussion method also, or it is the standard method to drill the deep bore wells. It is used for drilling wells of 80 mm to 600 mm diameter through consolidated rock material to a depth of 1500 meter also, and method consisting of sinking of casing pipe, usually larger diameter than well, with the help of rig. Rig is used to allow the sinking of casing pipe, and function of casing pipe is to support the hole also and to prevent the caving while drilling in progress. म्हणजेच जेव्हा ड्रिलिंग प्रोग्रेसमध्ये असतं तेव्हा बाजूची जी भिंत आहे ती पडून आपलं होल बुजू नये ह्याच्यासाठी केसिंग पाईप वापरला जातो. अँड बेलर इज युज्ड विथ द फ्लॅप वॉल टू लिफ्ट द पेस्ट ऑफ कटिंग अँड वॉटर. that is the flap wall, that known as a beller. Beller with flap wall is used to lift the cutting or paste of cutting and also water. After completion of drilling, casing pipe is taken out. That is important. Completion of drilling, that casing pipe is taken out because the material is consolidated. And equipment used are drilling bits, which is made up of steel and heavy iron, and which is heavy in weight, and length is 1 to 3 meter and weight is around 1500 kg. And pit is dug. Where well is sunk, there pit is dug. Pit means khadda, small. Then recharge of groundwater. Artificial groundwater reservoirs are developed by recharge of groundwater. Such a reservoir are advantageous than the dam reservoirs. This method is mainly used in modern days. So artificial groundwater reservoirs means कृत्रिम तळी डेव्हलप केली जातात आणि या कृत्रिम तळ्यात जशी शेततळी आहेत सध्या, त्या तळ्यात पाणी साठवलं जातं आणि त्या पाण्यामुळं ओव्हरऑल शेतातल्या पाण्याची पातळी वाढते. देन मेथड ऑफ रिचार्जिंग. देर आर 3 methods of recharging. First is the spreading method. Method of recharging the well or method of recharging. The spreading method. Spreading of water over surface of porous land. Water is temporarily stored in ditches or constructing the earth dikes or bunds so that water percolates down and join the nearby aquifer. Certain chemicals are added to the soil which may help in increasing the recharging rate. That chemicals are added in that soil to get it recharged early. Then recharge well method. Injecting the water in the boreholes is known as a recharge wells. Injected may be pumped under pressure or to increase the recharge rate. Ordinary wells are used as a recharge wells in dry season also. Ordinary wells are used as a recharge wells, or you have to construct separately also. And water used for recharging should be free from harmful bacteria. This method is used when spreading method is not applicable. That is the recharge well method, second method. And third method, which is all the time asked in competitive type of examination, that is induced infiltration method. Increase in the water table gradient from the source of recharge. Rainy type of wells are constructed near river banks. The percolating water is in well is collected through the radial collectors and then discharge is recharged into the lower level aquifer. That discharge is recharged into lower level aquifer. Please look at this figure. This is the stream or a river, and this is the pump house, and below that pump house rainy type of well is constructed, and the radial collectors are placed at the top level also, or upper level aquifer also, and lower level aquifer also. And this water is collected through radial level collectors and transferred to the bottom or lower level aquifer. And such a type of mechanism is termed as the induced infiltration method to recharge the well. And this is all the time asked in the examination. It is nothing but the collection of water from the upper level aquifer and transmit it to the lower level of aquifer through radial collectors, through the system of radial collector. That is important. Then we will discuss the seawater intrusion, sometimes asked in examination. It is interference of seawater with groundwater in coastal areas termed as a seawater intrusion. Seawater act with the groundwater and make the land infertile. Salt effluence is due to seawater intrusion. What are the causes of seawater intrusion? Waterlogging, capillary rise, excessive irrigation, and higher temperature for the longer periods are the causes of sea intrusion. And effects of seawater intrusion is adversely affect the bacterial activity. It corrodes the crop roots, it makes the soil impermeable, and it reduces the yield, even the growth of crops. So what is treatment for that salt effluence, or what is the treatment for that seawater intrusion? Leaching of soil with excessive flooding and addition of chemicals such as gypsum, that is CaSO4, to soil affected by sodium carbonate. And for more details, you may contact my administrator or you can email me. And once again, I am requesting you, for the people, engineers, students, to subscribe my channel if you have not subscribed the channel. And thank you for the people who subscribe my channel. And please watch my channel and watch my videos till the end to get some concept cleared in the civil engineering. Till then, bye bye, see you.